Oh, good. I'm glad you're here, because I want to show you how easy it is to texture these stylized rocks in Unity using Shader Graph. Together, we're going to create a shader that lets us start with a base texture that will even cover up ugly seams using TriPlanar projection. Next, we'll be able to change the colors using a top-down gradient that persists even if we rotate the rock. And we'll be able to adjust the midpoint and blend amount between the two colors. And finally, we'll be able to add moss, snow, or sand that accumulates only on the top parts or upper faces of the boulder, again using TriPlanar projection. So to start with, just add your rock to the scene. For now, it just has this default material. Let's right click and create a new shader graph, URP lit shader graph. Let's call this Mossy Rock Shader. Let it compile, and then afterward, let's right click on the shader and create a new material. Call it Mossy Rock Material. Because we right clicked on the shader when we created the material, it automatically assigned the shader, so that's great. Let's just assign this material to our rock. In my particular case, I just want to create a second one. Mossy Rock Material 2, let's say white. And I'll assign that to this other rock, just so I can show some color variations as I go through the tutorial. Great, so with our new shader open, let's start by just setting some of the graph settings. For the workflow mode, let's choose specular. For the alpha clipping, we'll turn that on, and it's allowed to cast and receive shadows. All right. Next, let's create a few categories. We'll create more later, but we're going to have to expose several fields in the inspector, and I think it would be best if we could just group them. Let's start with one called main texture. Let's create a second one called color gradient, and a third called general settings. The first thing we want to create is a texture 2D for the main texture. Let's call it main texture. We'll drag that up to the main texture category. We'll drag it into the scene. We won't do anything else with it for a moment. Next, under general settings, I just want to be able to control the specular color and the smoothness from the inspector. So let that afloat. Let's call it smoothness. Let's set it as a slider between 0 and 1, and let's actually default it to 0. We don't really want to have any smoothness right now. I'll move that to the general settings, and then I'll drag that to the socket. And same thing with the specular color. Let's create a color, specular color, drag it to the general settings. Let's actually set the default color here to all threes, 3, 3, 3, 3, 3, 3. And we'll drag that here to the specular color. All right. So to start with, let's set up the main texture and map it to the rock. Most of the time what you're going to see is people are going to connect the main texture to a sample texture 2D. This is a good idea if you've hand painted your rock or you have very custom albedo for it. In this case, I'm going to use a tileable texture with brush strokes or maybe a noise. So actually I want to use a TriPlanar node. Let's connect the texture to the texture socket. So what this is going to do is it's going to project this texture onto the rock from 3 different planes. One of the main benefits of doing it this way is if your rock, if it has seams in it, which mine has a pretty harsh seam, this will actually hide it. It doesn't care about that. Or if you have very small UVs, this is a really good solution. It also makes sure that it looks perfect in terms of the UV unwrap. So I really like TriPlanar rather than Sample Texture 2D for these types of tileable textures. You'll see what I mean later. The other values we want to expose in the inspector are the tile and the blend. With a TriPlanar node, the tile is like the scale. So with sample texture 2D, you're used to having tiling and offset. So being able to adjust the X and Y tile. You're not going to have that here, and it wouldn't work even if you enabled this. But what we can do is we can expose a float. Let's call it main texture scale. Drag that to the main texture category, and let's connect that to the tile. This is going to allow us to kind of zoom in or zoom out of the texture. Next, let's do the same thing for the blend. Main texture TriPlanar blend. So that is clear. The idea with the blend is that the TriPlanar node is going to project this texture using 3 different planes, which are going to kind of overlap each other, like from 3 different directions. And we want to decide if it should have like hard edges between them or blurry edges. Most of the time, this blend is going to be 0.5. That's usually what you want. And I think I'll make it a slider between 0 and 1. And I'll drag it to the right category. For the scale, I'm going to start with a 0.1 as well, and I'm pretty sure this is a slider between 0 and 1. Finally, we need to hook up these 2 nodes, or I guess sockets. So for the position node, we can simply add a position node. I meant socket. And it says we want it in absolute world space, so let's change it to absolute world, drag and drop. And for the normal, again, normal vector. Unfortunately, there isn't an absolute world option, but world is what we want here. Let me just organize this a little bit. I'm going to group these and call this main texture and make a note that it's TriPlanar. And so at this point, it's okay to go ahead and hook this up to the base color. But what we're going to see is that first it's just going to be white. And even if I were to assign a texture to this, let me go ahead and do that for both of my materials. You can see it's actually pretty hard to make out the details. But if we could add a color to this, I think it'd be much easier to see. So if we just quickly go back to shader graph, even the long term, we want to add a color gradient. Let's just quickly add a single color, and we won't even expose this. This is just temporary. Maybe make it like a brown color. And to add it, we'll just multiply. We'll multiply this color times the vector 4 and just put that into the base color. Then now if we save this, we'll see that our rock is kind of this color, but we'll be able to see the texture underneath. And I'll just quickly show off the effect of moving it around the world. You can see the texture is perfectly mapped to this, even if I rotate it. This is a really cool way to add tileable textures to meshes, especially if you have a bad UV unwrap or a lot of seams. So let's get rid of this temporary color in this multiply node. Remember, the goal is to create a color gradient. I'm going to fast forward to the future here, and this is what it looks like. With this, we'll be able to assign a top color and a bottom color. And we'll be able to adjust where the midpoint is, where the 2 colors meet. You might think, why not always just set it to 0.5? But this is actually based on where you put the origin in Blender, like when you exported your mesh. And if your mesh is perfectly in the center, well, if your origin is perfectly in the center of the mesh, then a 0.5 is going to work for you. But if you were slightly off or you didn't quite get it in the middle, that's where you're going to want to be able to nudge this up or nudge it down. And then the gradient fall off, rather than this like white meeting black, we might want to blend between the 2 colors a little bit and create a soft fall off. The way this is going to work, if I set this to 0.2, it's going to go up 20% and down 20% from that midpoint. So we can still move the midpoint around. So these are the 4 different fields we need to add to the inspector. I just wanted to show you why we were adding them. Cool, so let's add those 4 fields now. First, we want the gradient color top. Next, we want the gradient color bottom. Now we need a float for the gradient midpoint and another float for the gradient fall off. For the midpoint, let's make that a slider between 0 and 1. And let's go ahead and default it to 0.5 because most of the time that's what we'll need. And let's drag that down to the color gradient, to the category for color gradient. And the same thing with the fall off, a slider between 0 and 1, and we'll just default that to 0.2. I find that works. So this next section is a little complicated. So for that reason, I went ahead and built this part of the graph off screen, and I'm just going to explain it to you instead. But before I do even that, I wanted to hook up the result to the base color and demonstrate something. So let me save. If I were to choose 2 colors, let's say a blue and a red, here you can see that we've created a gradient which has the fall off in the midpoint. And you can see that it works even if we rotate it or move it in world space. If I switch to wireframe mode, it's a little difficult to see, but just imagine that there are some vertices in this mesh which are at the bottom, and the bottommost vertice would be 0% from the bottom because it's the bottommost. And the vertice that's all the way at the top, it's the highest, it's the topmost vertice, and so it's 100% of the way from the bottommost vertice. And the distance between them would be the size of the mesh, and like the Y height. If I were to rotate this mesh, now there's a new vertice that's all the way at the top, and a new vertice at the bottom. So the height has changed, and the topmost and bottommost vertices have changed. Okay. Now let me show you what this left section does. And I've drawn a crude diagram, but let's imagine that the terrain, the ground, is at a height of 0. It is 0 in like the world center. And that there's some sort of 3D sphere floating in space, but this is our rock. Let's imagine that the bottommost vertice of our sphere, or our rock, is 40 units from the terrain. And if you were to look at the transform of your rock or your sphere, it might say that that rock is 45 units from the terrain. But that's actually the distance from the origin of your rock from the terrain. So the bottommost vertice, let's assume that it's 40 from the terrain, and the topmost would be 50 from the terrain. If you were to subtract the topmost vertice minus the bottommost vertice, that would roughly give you the height. And if you took any vertice on that rock or the sphere and subtracted its y value from the minimum, that would give you the number of units from the minimum. So in this particular case, let's use this example of this vertice here, which we assume to be 42 units from the terrain. 42 minus the minimum gives us a 2. And if we were to divide that 2 by the total height, 10, we would get a 0.2. We actually already have access to these values. So we can use over here on the left, this position node in absolute world space to get this 42 for each vertice. It's the units from the world center. We can split it and get its y value. Then we want to subtract the minimum vertex. So we have this world bounds object, which gives us a min, max, and a size. Over here you see object, world bounds min, world bounds max, and world bounds size. And so we don't actually need to subtract the world bounds max from the world bounds min. We can just go ahead and access size.y. But the purpose of this left section is to give us a value for each vertice between 0 and 1 that represents kind of the percent from the bottom of the mesh. So the ones at the bottom would be around 0 and 0.1, and at the top would be 1. And we can use this when we're calculating our gradient. So if we wanted to put the midpoint right at the middle, we would know that the vertices that produce a 0.5 from this left side are roughly in the center of the mesh, no matter how it's rotated or where it's positioned. So that's what this left side is doing. The y value of the vertice minus the min divided by the height of the mesh, the size.y. So that's what this left section is doing. I hope that was clear. Moving on to this middle section, we're just simply going to plug in that 0 to 1 value for each vertice. Remember, this is for each vertice into a smooth step. And the idea here is that all we're going to do is take that midpoint and subtract and then add the fall off. So to get the top edge and the bottom edge, we're just going to subtract, 0.5 minus 0.2 and then 0.5 plus 0.2. And that gives us the region where the two colors will blend. And again, anything above that is one color solid, and anything after that is the other color solid. We have this saturate node afterward because a lerp expects a value between 0 and 1 for the T, and a saturate is just a clamp with the preset values of 0 and 1. So you could have just used the clamp. But we're lerping between two colors. If this produces a 0, we'll get the bottom color, and if it produces a 1, we'll get the top. And then anything in between is blended. So then we've hooked it up to the base color, and that's why we see that gradient. So all we have to is multiply the color gradient with our main texture and plug that into the base color. And when we save, go back into Unity, we can see that if we assign like a nice color at the top, maybe a darker variety at the bottom, then adjust the fall off, we get this nice blend, but it blends on top of our main texture. Something to note is that the specular color affects this greatly. The higher up you go, the more washed out and then eventually white your mesh will become. And then the further down you go, the darker your shadows will become, but the more, deeper the colors look. That's why I found a value of all threes. Looks really well. And then finally, I just want to show again that this gradient and this texture are going to work no matter how you rotate the object in world space. And because we use that calculation using the bounds min, bounds max, and size, therefore it doesn't matter where we put this in world space, the gradient will be the same. If we had just used the absolute world position, then moving this up and down in the world would actually have moved the gradient as well. Just wanted to point that out. So in the next section, we're going to add the moss accumulating effect, where the moss accumulates on the upper faces. In order to do that, we're going to need to add quite a few fields to our shader graph and expose them in the inspector. I thought maybe it would be easier if I showed you what they do, so that when we're building the shader, you'll have some sort of frame of reference. Let's start with, the moss texture. For that, I'm just using this cloud texture that I created in Photoshop. Basically, all I did was, using this color with all E's, I just kind of filled the entire area, and then went to filter, render, clouds, creates this. And the reason it looks tiled is because I used view, pattern preview. So after exposing that particular field, I just drag and dropped the texture here. The moss texture black mask, the reason this exists is because in this particular case, this moss texture is fully opaque and it looks like it has a white background with some gray clouds. But I wanted to be able to support a variety of different types of textures. I wanted to be able to support a transparent texture like this with little white splotches, but then the background is completely transparent. But I also wanted to be able to support if this had a black background instead of a transparent background. And I wanted to treat the black background as if it were like a transparent. Let me show you. So if I search for this, this is that same like splotchy texture, but it has a black background, and you'll notice the problem right away. Look how it tints like the stone or the dirt. Even though there's like no white splotches there, the black still gets rendered on top. Really, we want to treat this like it's transparent, and the way to do that is for us to find the brightness of each pixel. And if the brightness is like not enough, or maybe less than 10% or something like that, then we'll just treat it like it's transparent. And that's what this mask is going to do. So this allows us to set a minimum allowed brightness, and anything below that will be treated as transparent and will render nothing. And anything above that, like the white splotches, then that'll get rendered as the moss. And so this only exists, and you only need this if you would like to be able to use textures that have a black background and treat the black background as if it were alpha. But if you were just going to use textures that are transparent, or like I did here, not transparent, but also you don't want to treat any part of it like it is, then you don't even really need this. The next field is the color, and that's fairly obvious, but it allows us to use, if we wanted just a white texture, and create maybe like a sand effect, or maybe a snow. The other thing is that you could use a texture that is not grayscale. I think I have one from one of the asset packs. This is a green texture. And so when you want to use a colored texture, just set this moss color to set it to white, and that'll be the true color of the image. The next value is this moss intensity, and the purpose of it is just to be able to turn off the moss or turn it all the way on. When it's all the way on, you won't be able to see through the moss, and when it's any value in between, this is when we're going to blend between the stone and the moss. Next is the scale. You'll notice that when we use a moss texture, a TriPlanar texture, you don't have that tiling and offset that you typically do when you use a sample texture 2D. And the way it works is you'll be able to adjust the scale or the zoom of this using this scale. And that'll be hooked up to the TriPlanar's, I believe it's called Tile. And I'll show you that in a minute. But basically this is just how much you zoom or scale the texture. For the moss TriPlanar blend, the way that TriPlanars work, like that approach works, is you create 3 different planes and then you project them onto like your mesh. But you need a way to blend the 3 planes together. Maybe they should be hard edges and one just overlaps the other, or maybe they should be very blurry. So on the TriPlanar node, we'll be given the value for blend, and we can decide if it should be a hard edge or a blurry edge. With this particular texture, you can't see the difference. I mean, it looks a little streaky, I guess. Most of the time, you're going to want a 0.5 here. I found that that always seems to work the best. But I just wanted to expose that in the inspector in case our particular texture, were it very detailed, we would actually want to be able to adjust this. And the final value is the moss start Y, moss NY. The way this works is we want to render the moss on the upper faces, but not just the ones that are perfectly up facing, even these ones on the side that are kind of angled. This allows us to adjust, I guess, the threshold for which faces are allowed or considered up enough, pointing up enough. But what's cool about this is since I allowed the slider to go from -1 to 1, we can actually start rendering values underneath instead of on top. Watch this. I'm going to pick this rock up in the air, and right now we see no moss underneath. If I were to flip the start and end so that the start is greater than the end, I'm actually going to get the inverse effect. You'll notice we could render moss on the underneath surfaces, I guess. The distance between the two values, no matter what, which one's greater, but the distance between the two is kind of the blend between the values. And if the two values are very close, you'll see it's kind of sharp, and then it gets smoother as I increase the distance. Same thing if I flip the order. And yeah, so these are the new fields we're going to add. All right, so I went ahead and built the rest of the graph off screen so that I could use my time to just explain the final working solution rather than hooking up sockets and such. But first, I think we should just go through the new fields that are exposed to the inspector. The first one is the moss texture, it's just a texture. The second is this moss texture black mask float. It's a slider between 0 and 1. And for the moss color, it's just a standard color. The intensity is between 0 and 1. The scale, again, 0 to 1, with a default value of 0.1. I thought that was fine. For the TriPlanar blend, I'm going to default that at 0.5, and most of the time that's what you'll need. Again, slider 0 to 1. And in these two values, the moss start y and the moss end y, those will be a slider between -1 and 1. For the default value for the start, 0.2, and the end, 0.8. All right, great. So now that we covered the fields that we need to expose in the inspector, the last step is just to get into the graph itself. I think we should start over here. Basically, this is the same thing we did with our main texture. We're going to use a TriPlanar node and hook up the moss texture 2D to it. We're going to hook up the scale to the tile and the blend to the blend, the position in absolute world space, and the normal vector in world space because there is no absolute world space. I ended up splitting the RGBA into the 4 channels because I'm going to need them for the masks here in a moment. But let's not look at that. Instead, let's look at this very first mask. Our top priority is to make sure that the moss only renders on the faces that are pointing up to the sky, or sort of up, the upper facing normals. To accomplish this, I created a mask where we just take the normal vector in world space, and we only look at its y value. For instance, if it's facing directly up, that would be a 1, and if it's facing down, that would be a -1. But we don't want just perfectly facing, upward facing 1s. We're going to allow angles. So the way this smooth step is going to work, if we decide that the y value from the normal vector is at least this moss start y, say 0.7, then it's going to be allowed. We're going to render the moss, but to determine how much to render the moss, we're going to blend between the moss start and the moss end. If the value ends up being greater than the end, then it'll just be a 1, fully opaque. All you see is moss. And if it's in between, then there's probably going to be some opacity through the moss that you'll see the dirt or the stone. This creates our first mask, but there are several masks we're going to need. The second is to make sure that the moss intensity slider is some value more than 0. So if it's a 0, then a 0 multiplied with anything gives you a 0, And so we'll just exit right here. Nothing we do afterward will matter because we're going to produce a 0. Otherwise, whatever value we get on the left, we'll just multiply by, say, 20% opacity, 70%. The next mask that we need to support, which again we do just by multiplying the previous by some new value. And in this case, we just want to support the alpha channel. You may recall that I said that I wanted to support textures, which are completely transparent. They have no colored background. Or I also wanted to support textures which have a black background, but I want to treat those black backgrounds as if they were transparent. This is where I handle the transparent images, the images that are transparent but maybe have white dots. I multiply the previous value just by the alpha, which if it's a transparent pixel, that'll be a 0. 0 times anything, 0, we exit. Right above it, this is instead of the alpha background images, here's where I'm going to handle the black background images. It may look a little complicated, but the concept is simple. Basically, brightness is determined by looking at each of the color channels and just taking the color channel with the highest brightness. You see, these color channels are going to produce a value between 0 and 1. And we don't really care about the color, we just care about the intensity. So we look at all three and we take the maximum value between the red, green, and blue. And whatever that maximum value is, say 0.3, we plug it into this step and we just kick out any values below this black mask. So if our brightness is only 0.3 and our black mask is 0.4, then we're going to produce a 0 because a step node produces a 0 or a 1. And so the black mask allows us to mask out or eliminate any brightness levels below the black mask. And then we just multiply that 0 or 1 with what we've computed before. And if it's a 1, we'll just be going with whatever we had down here. And if it's a 0, we'll be rendering nothing. Really, the last part is that if we take our triplanar texture, which most of the time would be white, have like some sort of white dots or a white moss, we need to give it a color by simply multiplying it with a color here. We would be able to plug this into the base color node, but remember we have a main texture and we have a color gradient that we need to consider. The main texture with color gradient is plugged into the A node, or A socket, I guess. And our moss texture with color is in the B. And to determine how far between 0 and 1, or how much we should blend the moss into the main texture, that's where we just consider our masks that we've created thus far. And that final value goes right into the base color, and that's it. So for this final section, I just put together a little scene to show off some of the variations of sand, moss, and snow. I'd like to close by saying this is my first ever YouTube video, and I don't really know what I'm doing. So if you found any part of the video helpful, or have some suggestions for how I can improve future videos, I'd really appreciate it if you could just mention that in the comments. I already have some ideas for other videos I'd like to make in the future, such as maybe painting textures in like leaves in Procreate or Photoshop, some of the brushes I use, some seamless or tileable textures, or maybe modeling some game assets in Blender and creating stylized PBR textures in Substance Painter, like I did with this treehouse or this mailbox. Another idea I had was retexturing third-party assets to kind of make them sort of your own. Like I did here with this, I guess I call it the Fishman. The one on the right just came from an asset pack, and I was able to edit it in Blender and then re-export it back to Unity without breaking the armature, which is the really difficult part. So I wouldn't mind making a video showing how to do that. And finally, I wouldn't mind making a devlog about a tower defense game I've been making over the past 6 months. So if any of those ideas sound interesting to you guys, then just leave me a comment with some suggestions or even advice or criticisms. Anything is welcome, honestly. So, oh, and finally, I should have mentioned this at the beginning, but if I didn't, some of the textures, like the brushstrokes texture, this one, I'll leave a link in the description to my GitHub where you can just download this if you want it. I think I also included the noise texture I created, like for the which I use for the snow and the moss. So yeah, thanks for stopping by. I hope you visit again soon, and until then, keep building games.